Hey everyone. Okay, so today we're going to click on modules, scroll to the bottom of the page. Best thing to do. So you've got your attendance check-in today. Again, not the warm-up. If you're a Roar at Home student, do not complete the warm-up. Complete the attendance check-in. That will be in this module here. That's not the right one. You should have one for Thursday up there. So today we want to talk about literal equations. So what you need to do is you need to go here and you need to get these journal slides. So it's 2 slides and you're going to need to find yours. You need to find your journal on your Google Drive and you need to copy these over. So remember, you can hold down Shift, click the last slide, right click and copy. And then you can go all the way to the bottom. And if you just click on the last slide, right click, paste, it'll put them in there. So your table of contents needs to say Unit 1, Lesson 4. And this is writing and solving equations. Yesterday, actually. That was yesterday. Today, you should have 1.5, which is going to be literal equations. Okay, so this one right here for yesterday, which I think I did in the video with you guys, should be linked to slide 15, and literal equations, I think should be linked to slide 17. Okay, so whatever slide you posted those in as, you can always go down to the bottom and check. Now mine's not complete because I'm working with my classes today. So I think it's going to be 17 though, or it might be 18. It might be 18. But figure out which slide you need to link the literal equations to. Okay. So make sure you're linking them because pretty soon we're going to have we already have almost 20 slides in here. So it's going to be really hard to start scrolling through and find what you need to find. So this is why this linking is going to be really, really helpful. So make sure your table of contents looks like this and they're all linked to the correct slide. Okay, so I'm going to go over to my iPad now. Where I'm writing, you're actually going to be typing in your journal slides. So let me make this larger. Okay, so Unit 1, Lesson 5, literal equations. So what are literal equations? It's almost a tongue twister. It's hard for me to say sometimes. So a literal equation, so here's where you're going to type in all these blanks. You have places to type, but I'm going to write a literal equation. And you can pause the video at any time. Typically it's only letters or variables, okay? Typically, you just don't have a lot of numbers, or you have a lot of letters and variables in your literal equation. So you can actually think of formulas. Think of formulas that are used in math. We use them both in math and we use them in science. Okay, so remember, pause the video at any point to catch up with the typing. So these examples here are typically literal equations, like area equals length times width, right here. That's a literal equation. That's a formula, right? There's no constants in this formula. Well, what about this one? E equals mc squared. You may not have talked a lot about energy and Einstein's famous equation for energy, but E equals mc squared, that's a literal equation. There's no constants in there. So how do you solve a literal equation? Well, it's just like solving regular equations. I am running out of room here, guys. Except you aren't actually eliminating anything. You're not eliminating or simplifying any numbers. Okay, so all that simplifying and eliminating, we're not doing that. All you're doing is just isolating the given variable. So they are going to tell you what to solve for. Okay, so don't get overly confused. Again, pause the video if you need to catch up with that. Don't get overly confused. just think of it like we have a bunch of variables. Eventually, we will know what to plug in for those variables, but we don't right now. We can still draw our line down the center. So this one, solve D equals RT. This is distance. Distance equals rate times time, right? So let's say I'm driving to Walmart and I'm driving 60 miles an hour. I'm probably speeding if I'm driving to Walmart Henderson. So if I'm driving 60 miles an hour, that's my rate. And I drive for, 2 hours somewhere. Maybe I'm not going to Walmart. I'm going somewhere. I drive 60 miles an hour for 2 hours. How far have I driven? Well, you guys right now are going, oh yeah, that's your distance is equal to, well, if you're going 60 miles an hour and you were driving 2 hours, 60 times 2 is 120, right? You probably went 120 miles, Ms. Robinson, if you kept that constant speed of 60 miles per hour. Okay, well, this one says, well, instead of that, maybe I don't want to know distance. Maybe I have the formula, but I really want to know what R is. So solve for R. So here's my R right here. So what I really want this equation to say, instead of D equals, I want it to say R equals. So I look and I say, well, what's happening between R and T right now? My rate, whatever it is, I multiply times my time to get distance, right? So rate is multiplied times time. They're sitting side by side. That means multiplication in algebra. Okay, so, well, if I do the opposite, if I divide by my time on both sides, I can't really cancel anything out except over here. T divided by T, those are going to cancel. So all I'm left with on this side is R, and I'm left with my distance over time. So rate actually is equal to your distance divided by your time. Yeah, right? However many miles you drove and however long it took you. Miles per hour. Miles divided by hours. That's a rate. Yeah, okay, that should make sense. Okay, well, let's look at another literal equation, okay? Again, this is actually the standard form for lines. Now, you guys have seen this. We're going to manipulate this here because this is how we're actually going to solve a lot of literal equations together. Okay, so this one says solve this equation for y. So where is your y? When you're solving a literal equation, you're going to have to look. You're going to have a lot of variables. I see I have an a, an x, a b, a y, and a c. So there's y right here. I want y by itself on one side. So if I think of this, you can think of it like really there's numbers in place of all these letters, okay? Don't let it confuse you. I have a term that's sitting out in front. I have a times x, and a must be positive. I don't have a negative sign there. So if it's positive, can I get it to cancel out? What if I subtracted that? Because remember, a is multiplied times some number x. I don't know what either one of those numbers are, but it's still just a number when I multiply them out if I knew what they were. So you can still add and subtract them, these letters, these variables, as if they were numbers. So I could just say, hey, well, if I subtract ax on this side and I subtract it on this side, well, won't it cancel out over here? And you guys are like, yeah, it will. So what am I left with on this side? By. Now, what am I left with on the other side? This is where I find students get most confused. Well, I have c, and I have to subtract ax. Now, are the term c and the term ax like terms? Do they have anything in common? No, they don't have any variables in common, so they are not like terms. So here's all you need to do is just write it down. C, take away ax, whatever that is. I don't know what that is, but take it away. Okay, don't stress too hard when you go to write things on the other side. That's where I find students have the most trouble. But you just literally, we don't know what it is. All we can do is write it down. Okay, we're getting closer to getting y by itself. That's what we were trying to do, right? We wanted to solve for y. We wanted to say y equals. Well, y is still multiplied by b. Now, I don't know what b is, but it's some number. I don't know yet. It's multiplied times b. So in order b and y are multiplied, the opposite of multiplication is what? Division. So I need to divide by b, because then b divided by b will divide out to be 1. But remember, whatever you do on one side, you better do it on the other side too. Okay, so on this side, I'm just left with y equals. And then I have students say, I don't know what to do with the other side. You're right, you don't. We don't know what C is. We don't know what A is. We don't know what X is. We don't know what B is. Just write it all down, guys. Write it down again, and you're done. So whatever y is going to equal, if I knew the value of C, A, X, and B, I could figure it out, but I don't. But I know if I did all of those operations, if I take C and I subtracted A times X and I divide all that by B, that would give me my value for Y. Okay, so literal equations actually do come in handy. And I'm going to explain to you why we need to be able to solve them. We won't always be rearranging formulas. But how we do rearrange formulas is, here's your turn. I want you to work, get a piece of paper, and you should have already had a piece of paper. If you didn't write these down, do that. And I want you to take pictures and put them on this page. Now on this page, I want you to get another piece of paper and you're going to work these 6 problems on your piece of paper. So one is very similar to the example that I worked up here for you. Okay. The very first one. 2, I think you can do 2 on your own. So I'm going to leave you. I want you to try and figure out 2. Now, 3, 4, 5, and 6. This is actually how we solve literal equations in Algebra 1. And I'm going to show you what that looks like. So I think I'm going to work number 3 with you right here. So I'm going to write down my equation. 2x plus 3y equals 9. So this is a literal equation. Yes, it does have some numbers in it, but it also has 2 variables. It has x and y, okay? So this is how we solve literal equations. This is where it actually applies to us in Algebra 1. So we like to talk about it when we just have no numbers. We don't have any constants or numbers we just have formulas like 1 and 2 right here. We like to actually talk about that with you guys because you need to see those because you will see them sometimes. But this is really like number 3, 4, 5, and 6. This is how we're going to see it. So what we would do, the first thing is we would draw our line because that's what we do. Now it's telling me to solve for y. So here's my y right here. This is what I want by itself. So I see I have 2x sitting out beside it. So I need to get that away. I need it to cancel out on this side. It's positive, so I can subtract it on both sides. Okay, so it's gone. I'm just left with 3y on this side. Now I have 9 minus 2x on the other side. Are 9 or negative 2x like terms? I hope you're saying no, they're not. They don't have a common variable. So we're just going to write them down. Now, I'm really close to getting y by itself. I just have one step. 3 is multiplied by y, so I need to divide by 3. Now, there's 2 ways to do your division here. This is how I would suggest it. Both ways are correct. I'm going to cancel those 3's out, right? Because 3 divided by 3 is y. So now when we divide by 3 on the other side, you can divide everything by 3. That is completely legal. You can do that. Or, and this is how I suggest you do it, you can divide each term by 3. It's the same thing. It makes no difference how you do it. I suggest you start getting in the habit of doing this. Divide every single thing on that side by 3. Well, 9 divided by 3, we can simplify this a little bit here. 9 divided by 3 is just 3. And I'm going to subtract, well, 2 divided by 3, well, that's just the fraction 2/3. I'm going to leave it there, and I still have my x beside it. Now, I want to rewrite this. You don't have to do this part, but I want to rewrite this because I want to show you where this is actually going to apply to us, and we're going to see this really soon. This is actually the same thing as y equals. So this is the same thing. We could write, these are both the same. I'm just going to swap these pieces. I'm going to do my negative 2/3 x first, and I'm going to put my 3 out on the end. Ooh. Now, I hope this looks very similar to something called y equals mx plus b. You are going to remember that. Y'all do y equals mx plus b. Y'all love it. Y'all always are like, oh, yeah. This is why we need to know how to solve literal equations. Move things around that have more than just one variable in them. Because we are going to have to solve for y so that we can graph. And coming up in Unit 2, we're going to start seeing this. Unit 2 and Unit 3 especially. Really quickly, we're going to be solving for y a lot. And so that's what we're going to call it. We're going to say solve for y. So all these solve for y's, we're going to go ahead and start practicing that because we are solving equations. It's the same steps of solving equations, okay? So try these. That leaves you just 5 problems to try on your own. I want you to work them on paper, and I want you to take a picture, and I want you to put your work on this slide. So I'll grade that when I grade journals at the end of the 9 weeks. So you need to make sure that work is in your journal. I can't stress that enough. It's very important that you are putting this work in your journal when you're watching the videos, okay? So try those. If you start struggling with them, send me a message, and I'll go over, I'll make a video, or we can schedule a time to do a video conference and work some of these problems together.